Welcome. Our class today will be divided in two sections. We will begin with the ultrastructure of the respiratory epithelium, and in the second part of the class, the Dr. Elisa Uribe will resume some clinical diseases that are related to the alteration in these structures. Well, let's begin with an activity group. You should divide in two groups, A and B. Each group will receive a clinical case and a list of questions that you must answer. You have 15 minutes to perform this activity. Also, each group must assign a person to perform later an argumentation about the question that you will have of the cases. Don't worry, I will approach each group to see if you have any doubts or questions. Well, let me finish the first activity with a summarizing of the conclusion that we get. Here, the A group analyzes the clinical history of an infant whose recurrent infection pointed to an alteration in the function of the respiratory mucosa, while then the members of the B group evaluated the clinical data of a male with infertility and alteration in the motility of the spermatozoon. Now, let's think together. Which ultrastructure specialization share both the airway mucosa and the spermatozoon? Can anyone tell me which structure?
The cilia and the flagellum.
Sorry, can you repeat that?
The cilia and the flagellum.
Perfect. Both. Could anyone name epithelium or cells of the human body that have these specializations? Okay, let's now review the function that the cilia and the organelles with cilium structures perform in the organism. We can see that they are related to the movement and the cellular transport, also in the embryonic development, and at the same time they participate in the cellular polarity and allows homeostasis status. Finally, they are involved in sensorial functions. How can these structures perform this myriad of functions? These functions are the result of a complex genetic and morphologic structure, namely primary cilium, that comprise around 2,050 proteins. Well, now we have this graph that represents a cross-section of the cilia. As you can see, we can reveal the arrangement of the microtubules in a structure, namely 9+2. In this arrangement, 9 Adler doublets of microtubules are in a steady position in the periphery thanks to bridge of nexine, of this protein nexine, while two singlet microtubules are in the center of the structure and are stabilized by radial spoke. This structure that you can see have dynamic arms or DNAM. These dynamic arms are related to the movement in motillar cilia. These 9+2 structure work together thanks to the dynamic arm in the movement of the cilia. So we can see that the complex that this structure has. The alteration of these denying arms obstructs the movement of the cilia, and this condition is verified in patients with Kartagener Syndrome. That was the condition of the clinical case A and B that you analyzed before. Finally, we have this table that illustrated the many genes that are involved in the Kartagener syndrome. As you can see, there are several genes that are related to the proteins that form the DNA arms. Any of these mutated genes can be inherited in recessive form. Okay, so we see that the structure of the cilia is a complex genes and morphologic structure. We also see the many functions that this structure has, and we can extrapolate the clinical consequence that this mutation can provide in a person. So we will finish here, and we wanna have a break. After the break, you will have the next class with Dr. Uribe. The doctor will proceed with the second part of the class, and you will see some clinical diseases that are related to the alteration of this structure. Okay, see you next.